you. Thank you, Molly. All right. What is the radius number, Annabella, since you were since you're on a roll and got the 8 right, what number goes in here for radius?
Would it be 2.5?
Right. So does it make sense to you, Alex and Aaron, that this is a big circle that this is creating? So this is the radius. It's the distance from the center point, which we also give a fancy name, but that is on the first video, so you'll see that. All right, now we're up to the second guy. So Abby, what's the force of B? So you're looking here.
You mean like 0.5?
That's his distance, so we'll put that under a R. Do we know the force that he's creating?
I don't think so.
Right, because that's what we're looking for, weighted B. All right, so let's go on. Abby, try this C guy. What's his force and radius?
3
And,
and 1.3.
yeah, except that's where we have to tweak it. This isn't right because we need the distance from him to the fulcrum.
Oh,
So could you do that addition? We're going to have to add these two numbers.
is it 1.8?
Yeah. And Abby, since you're on a roll, what is the acceleration of this still stick?
Is it 9.8?
No.
Oh, 0.
Right, there's no acceleration. All right, what you were confusing with is G, which is acceleration due to gravity, but this thing is still. So, all right, so now we have a tippy tap to do. So, calculators out, multiply, add, subtract, divide, all those fun things. So, Jonathan, to get credit for seeing this video, recall that you have to write down notes on it. So you're going to stop the video whenever you need to in order to catch up to what we're writing. And you get the tippy tap as well. So turn it off and see if you can get a number for the weight of B. And you have to multiply here and here, add those two together, move it over there, and divide by 0.5. Anyone? What'd you get, Hannah?
0.8.
Pardon?
50.8.
50.8. Anyone?
Yes.
Confirm? 50.8. Why didn't I get that? I probably did it wrong. What'd you get when Hannah, do you have any of the steps in front of you?
I have some of them, yes.
What's 8 times 2.5? Oh, I bet I know what's wrong. I'm right, you're wrong, and it's because I led you astray. There's a sign problem here. 2 hands up, everybody. Ah, good. The sign problem is right here because this is a negative torque.
Are they all negative?
No,
it's just that
this one's negative. This one's we established it before we started and then forgot to put it in our math. All right, tippy tap again. Sorry. Jonathan, did you catch that? This torque caused counterclockwise motion. It's negative. These two are positive. So in our math, we needed to put that negative sign, and we failed to do that. All right. What you got, Molly?
Negative 29.2.
Negative.
No, it's
Even though it
positive.
should be positive.
Because it still is positive because you have to move it over before you divide.
Oh, you're right. Yeah. So,
So positive what?
29.2.
All right, I'll just do the 29 newtons. All right. All right. So that is kind of bringing all of us up to date on torque, and that is a typical torque problem. And you'll see a few more in the video, which if you can follow this, then you can follow anything. Aaron or Alex, do you have any questions initially on that? Okay. Not too bad, is it? All right. We had some O's to do. Raise your hand if you actually did this lesson without taking a pass. You did? Just you? Yeah. Did you check it with the back?
No.
Okay. What'd you get on
I don't know if it's
6.6?
right. I got 1.4.
That's correct. And what about number 6.7?
1.8.
That one I got 18, so that's kind of strange.
Oh, maybe is the decimal point.
I don't know. All right.
I'll check it with
Check
the
it in the back, you'll find your mistake. All right. All right, what I'd like you to do right now is do these 3 problems. One of them is a tension problem, and 2 of them are torque problems. If you want to go to the second and third while torque is fresh in your mind, number 3 is very similar to what we just did. So I advise that you start with number 3, and then work backwards to 2. And 1 is the old tension hanging star problem. I did this hot star problem. So, Jonathan, I'll leave one of these with Miss Tammy, and that's your classwork, and then we're going to go on. So we're going to cut the video off and catch you later. Bye.